Dear students, our today topic is Coulomb law. What is Coulomb law? This is the basic law of electrostatics. This Coulomb law it is similar to our gravitational law. This Coulomb law it states the force which exists in between two charged particles. Suppose this is our charged particle Q1, another charged particle Q2 lie at a distance small r, then Coulomb said that in between two charged particles either there is a force of attraction or a repulsion depending upon the nature of charges. If this Coulomb force it is attractive for unlike charges and repulsive for a like charges. So the magnitude of the force which exists in between these two charged particles F it is directly proportional to the product of magnitude of charge of two charged particles and inversely proportional to the square of distance in between them. If we combine both of them in this way, then this relation further can be written as Q1 Q2 over R square. This proportionality sign it can be removed by a constant k. So the value k is known as a Coulomb constant or electrostatic force constant, and value of this k it is equal to 1 upon 4 pi epsilon naught. Here this epsilon naught is known as absolute permittivity. When Coulomb performed this experiment and find the value of this k, he find that value of this k it is equal to 9 into 10 to the power 9 Newton meter square per Coulomb square. And with this he is able to define the unit of permittivity, absolute permittivity, its dimensional formula and its value. So its unit. So this relation further it can be written as 1 upon 4 pi epsilon naught Q1 Q2 divided by R square. So this is the basic formula of a Coulomb law, and its unit can be derived from here. Epsilon naught it can be written as Q1 Q2 4 pi F into R square. And when we write charge, it is expressed in SI system in term of Coulomb, having notation C. Coulomb C, 4 pi it is constant, F Newton, distance in meter square. So it become as equal to Coulomb square per Newton per meter square. So this is the unit of epsilon naught. From this relation, we are also in a position to find out its dimensional formula. Its dimensional formula, it is equal to, for charge, we can write it as current into time, IT. This is force. Force dimensional formula is mLt minus 2, distance L square, current has dimensional formula A, ampere, time has T, so it is equal to A square T square, and it is further equal to m L cube T minus 2. Further, it can be rewritten as m in numerators, m minus 1 L minus cube, and it cancels with this T minus 1 and a square. So this is its dimensional formula. So by using this relation, this is the relation showing Coulomb law, we are able to find out its unit as well as its dimensional formula. With this relation, we are also able to find out its value. So from here, this relation, which can be written as epsilon naught q1 q2 4 pi f r square. Here we assume that if q1 is equal to q2, which is equal to suppose 1 coulomb, and f has magnitude 3 into 10 is power 9 newtons, and r distance in between two charged particles is 1 meters, then epsilon naught has value equal to 1 coulomb, 1 divided by 4 pi. 4 pi has value 3.14 into 3 into 10 is power 9 into 1 square. Then its value comes as equal to 8.85 into 10 is power minus 12 Coulomb square per newtons per meter square. This is value. This is the universal value. This value, it always remain constant for everything. And from here we can also define 1 coulomb charge. So how we can define this 1 coulomb charge? Again, we use this relation. This is the basic relation. Let this equation first, basic relation, and then we write this relation as this one. Definition of Coulomb. Definition of 1 coulomb. Definition of a Coulomb. We use this relation. F is equal to 1 upon 4 pi epsilon naught q1 q2 over r square. This k, this is the k, having value 9 into 10 is power 9 newtons. Force in between two charged particles, it is also 9 into 10 is power 9. And if q1 is and q2 both are same and their value is equal to 1 coulomb each, and distance in between them is 1 meter, then by using this relation we have c square c, which is equal to q, it is equal to 1. We can also take it as equal to q each, q square, or from here this charge q square, it is said to be plus minus 1 coulomb. So from here we can define 1 coulomb. Our charge, it is said to be 1 coulomb. If two equal or opposite charge separated by a distance 1 meters experience either force of attraction or repulsion whose magnitude is equal to 9 into 10 raised power 9 Newton, then we can say the charge present there is a 1 newtons.